are watching Darasa Online.
Hello students, this is Darasa Online. My name is Edi Gamshana. I come from Kibaha Secondary School. I'm teaching basic applied mathematics. In this part of presentation, we are going to review questions concerning to the topic of trigonometry. And the subtopic that we are going to discuss are, number one, we have trigonometric identities. Number two, we have sine and cosine rules. Join with me till the end of this presentation. Now, students, let us start with the trigonometric identities. And this part, we are going to derive some formulas which are applied in trigonometric identities. Now, students, consider a unity circle. Consider a unity circle with x and the y axis. Here we're going to consider a unity circle with x and the y axis. Let us make a sketch here. This is our unity circle. Now let us draw y axis. This is our y axis. This is our y axis, and then followed by x axis. So here we have x axis. Call this x axis. Now we have the center of the circle, call it A. That is the center of the circle. And any point from the center of the circle to the point of circumference, this is called radius. So here you just write R. That is any distance from the center of the circle to any point of the circumference. That is the radius. My dear student, suppose here we have a point P, called point P. And here there is angle included, call it angle theta. Call it angle theta. And any distance parallel to y-axis, any distance parallel to y-axis, call it y, that is a y unit. You can call y, that is y units. Why? Because it is parallel to y-axis. And any length which is along x-axis, you can call that is x, that is x units. Why? Because it is along to x-axis. Now, here we have a coordinate now. Point P, that is a coordinate. That a coordinate, call it that x, comma y. That is your coordinate, x, comma y, because we have the length x, that is from O to somewhere here, call it Q. And for y-axis, that is QP. So we have a coordinate that is P, X, comma Y. Now, remember, sine of any angle, that is sine theta, this is given by opposite side. We call opposite side divided by hypotenuse, that is hypotenuse. Remember, here is an angle theta. So if we are talking about sine theta, the opposite of angle theta is y unit. Okay, therefore we say sine theta is equal to the opposite side of theta is y. So that is y over, then we have the hypotenuse. Our hypotenuse is r, that is the radius, any distance from the center of the circle to any point of the circumference. So here we just divide by r. Now let us make y the subject. Let us make y the subject as follows. So y will be equals to r sine theta. Now call this equation 1. This is equation 1. Again, let us proceed for cosine. Remember, cosine of an angle, that is cos theta, is equal to, that is adjacent side, over then hypotenuse. Remember, our hypotenuse is radius. So here, of course, divide by, that is hypotenuse. That is hypotenuse. Therefore, we substitute values for adjacent side and the hypotenuse. Now, cos theta will be equals to our adjacent side. Here we have x unit. So we just write xc. Then over our hypotenuse, that is r. So this one is over r. Now again, we are going to make xc the subject. That is xc is equal to r cos theta. Now call that one equation 2 because we have already created equation 1. Now that is equation 2. Now my dear student, applying Pythagoras theorem. That is apply Pythagoras theorem, which states that OP squared, that is all distance OP squared, that is equal to, then we have opposite squared called PQ, that is PQ squared plus adjacent squared, which is OQ. So this is OQ squared. That is the Pythagoras theorem. But what is OP? OP, that is the radius, the distance from the center of the circle to the point of circumference. So here we have r squared. Then we have PQ. What is PQ? PQ, that is y. So here we have y squared. Again plus followed by OQ squared. What is OQ? OQ is XC. That is XC squared. That is Pythagoras theorem. Now call this equation 3. This is equation 3. Now we have 3 equations. Equation 1, then we have equation 2, and the equation 3. Now we say substitute equation, that is equation 1 and equation 2 to equation 3 to equation 3. We are going to substitute equation 1, equation 2 to equation 3 as follows. Now equation 3 starts with the r squared. So we have r squared, which is equal to, then followed by y squared. It means value of y is r sine theta squared. Then plus x squared, that is plus, we have x is found in equation 2, that is r cos theta squared. Now we have r squared is equal to, remember, this one will be r squared, then sine squared theta, plus, again you open up the bracket, that is r squared, then cos squared theta. Then here r squared is common. R squared is common for sine and cos. R squared is common. So we write r squared out of the bracket. So we are going to remain with, you take r squared, sine squared theta divided by r squared. So we are going to remain with sine squared theta plus, then again you take r squared cos squared theta divided by r squared. So the remaining is cos squared theta. Now student, we just divide by r squared from both sides. So here we say divide by r squared from both sides. Divided by r squared from both sides. So we are going to have r squared over r squared. That is left hand side, which is equal to r squared over r squared sine squared theta plus cos squared theta. That is right hand side. Now, on simplifying, we are going to have, that is r squared will remain with 1, which is equal to, again here r squared will remain with the sine squared theta plus cos squared theta. Or we can write as, or that is sine squared theta plus cos squared theta is equal to 1. So my dear student, this is our first identity formula. That is first identity formula, which connects sine and cosine. The formula can be written as, that is, on making sine squared the subject, we are going to have, that is, sine squared theta will be equals to, then we shift cosine squared in our right hand side. So we are going to have 1 minus cos squared theta. So this is another identity formula. Or if we make cosine squared the subject, the formula will be, that is cos squared theta is equal to, that means we are going to shift sine squared in our right hand side. So we are going to have 1 minus sine squared theta. So this is another identity formula. Okay, my dear student, let us proceed with the other identity formulas. And this time, we are going to derive the double angle formula. So that we call double, that is double angle formula. We are going to derive the double angle formula. My dear student, recall, that is, recall the compound angle formula for sine. Recall the compound angle formula for sine. That is sine of angle A plus B. I'm sure you remember this, which is equal to, that is sine A cos B plus, the next is cos A sine B. That is a compound formula for sine. When we add two angles, we have angle A and angle B. Now, from this point of view, suppose angle A is equal to B. Suppose if A is equal to B. Suppose A is equal to B. What will happen? This will be sine of A plus A is equal to, we have sine A, then cos B. Instead of cos B, we write cos A. Why? Because A is equal to B. So that is cos A. Again, plus. The next is cos A. So here we have cos A. Then we have sine B. Remember, A is equal to B. So we just write sine A is sine 2A. That is A plus A. And again, if you look very careful, sine A cos A is the same as cos A sine A. So we just write this is equal to 2 sine A cos A. So this is another identity formula we call double angle formula for sine. That is double angle formula for sine. Let's call that is this is double angle formula for sine. Now again, my dear students, let us proceed with the compound angle formula for cosine. Again, here we recall the compound angle formula for cosine. This time we are going to recall the compound angle formula for cosine. Remember, when we want to add two angles for cosine, that is cos A plus B is equal to, you remember the formula, that is cos A cos B minus, the next is sine A sine B. That is a compound formula for cosine of two angles. Now again, we use the same idea. That is if A is equal to B. That is if angle A is equal to angle B. That will be cos of A plus A is equal to cos A. Here we have cos A followed by cos B. Instead of B, we write A because A is equal to B. So here we have cos A minus, then we have sine A, that is sine A, followed by sine B, but remember B is equal to A. So that is sine A. My dear student, this will be equals to cos 2A, because A plus A, that is 2A, which is equal to, here we have cos A times cos A. That will be cos squared A minus, then we have sine A times sine A. That will be sine squared A. So my dear student, this is another identity formula we call double angle formula for cosine. This is another identity formula. And of course, we call this is double angle formula for cosine. Again, my dear student, let's proceed with the tangent. This time we have tangent. So recall the compound angle formula for tangent. That is tangent of two angles. Tangent of two angles. Remember, when you have tan of A plus B, tan A plus B, you remember, tan A plus B is equal to tan A plus tan B over, that will be 1 minus tan A tan B. That is the compound angle formula for tangent. Now we are going to apply the same concept as we did in sine and cosine. That is if A is equal to B. That is, if A is equal to B, we are going to have, that is, tan A plus A is equal to, so here we have tan A, no problem, that is tan A, but the second one will change, will be tan A. Why? Because A is equal to B. That is tan A over, for the denominator we have 1 minus the product of tan A and tan B. So that is 1 minus, we have tan A, then followed by tan A, because A is equal to B. So we have again tan A. Now, A plus A, that is tan 2A, which is equal to tan A plus tan A, that is 2 tan A, that is 2 tan A, over, we have 1 minus, here we have tan A times tan A, that is tan squared A, that is tan squared A. So this is another identity formula we call double angle formula for tangent. That is double angle formula for tangent. Now, my dear student, let us see how we can apply these identity formulas. Identity formulas can be used to prove the given equation, but also can be used to solve the given equation. Now, let us start with the proving the given equation.
You are watching Darasa Online.
Example, called example 1. That is called example 1. Prove that sine 3 theta is equal to 3 sine theta minus 4 sine cubic theta. Prove that sine 3 theta is equal to 3 sine theta minus 4 sine cubic theta. So, in this type of equation, we have to choose either to take the left-hand side or the right-hand side. Now, suppose we take the left-hand side. Suppose we take the left-hand side. That is sine 3 theta. In our left-hand side, we have sine 3 theta. Now, sine 3 theta, this can be written as sine 2 theta plus theta. That is sine 2 theta plus theta, because 2 theta plus theta is the same as 3 theta. Now, from this point, you can recall the compound angle formula for sine. That is applying the compound angle formula for sine. So remember, that is sine A plus B. This is equal to sine A cos B plus cos A sine B. That is the compound angle formula for sine. Now our A will be equals to 2 theta, and B will be equals to theta. Okay? That angle A will be the same as 2 theta, and the angle B will be equals to theta. Now, let us expand this one. Now, that is sine 2 theta plus theta will be equals to, now we have sine A cos B. That is sine 2 theta cos theta. Sine 2 theta cos theta. Why? Because A is equal to theta and B is equal to theta. Again, that is A is equal to 2 theta and B is equal to theta. That is plus cos A sine B. So we have cos 2 theta sine theta. But you remember the formula for sine 2 theta and the formula for cos 2 theta. That is double angle formula for sine and double angle formula for cosine. So here we are going to have, that is 2 sine theta cos theta bracket followed by cos theta. That is cos theta plus, remember the double angle formula for cosine. That is cos squared theta minus, that is minus sine squared theta. Then the last identity here is sine theta. Now you are in a position to open up the bracket. We just open up the bracket by taking 2 sine theta cos theta times cos theta. So we are going to have 2 sine theta cos squared theta. Why squared? Because cos theta times cos theta, that is cos squared theta. Then plus, again we are going to open up the bracket here by taking sine theta times cos squared theta, and again minus sine theta times sine squared theta. So we are going to have cos squared theta sine theta minus then sine squared theta times sine theta. So here we have sine cubic theta. Why? Because here we have power here is 2 and here we have 1. So sine squared theta times sine theta, we have sine cubic theta. Now, my dear student, remember, remember the value for cos squared theta, and again for the second identity cos squared theta. You remember them. That is 2 sine theta bracket of, remember the value for cos squared theta, which is equal to 1 minus sine squared theta, plus, again, remember for cosine squared theta, that is 1 minus sine squared theta, bracket of sine theta, minus the last trigonometric ratio we have sine cubic theta. Now again, my dear student, we are going to open up the bracket by taking, that is 2 sine theta times 1. That is 2 sine theta. Minus, this time we have 2 sine theta times sine squared theta. That will be 2 sine cubic theta, plus, then again we open up the bracket here, that is sine theta times 1. Here we have sine theta, minus, then we have sine theta times sine squared theta, that is sine cubic theta, then minus sine cubic theta. Now, if you look carefully, we can collect all like terms, all related terms. We can collect like terms. So here we say collect, that is collect all like terms together. Now, what are the like terms here? We have 2 sine theta. This will go with that is 2 sine theta. This one is the same as sine theta. But again, we have the sign with the cubic. That will be the same. Now, collecting like terms, we take, that is sine 2 theta plus theta is equal to, then we start with, we have 2 sine theta followed by plus, that is plus sine theta. Then for cubic we have minus, that is minus, we have 2 sine cubic theta, that is minus 2 sine cubic theta. Then we have again minus sine cubic theta. So again minus sine cubic theta. And the last one, sine cubic theta. So here, minus sine cubic theta. So there is another sign here. Sine cubic theta. Now, 2 theta plus theta, again, that is sine 3 theta. So here we have sine 3 theta, which is equal to, now, 2 sine theta plus sine theta, that is 3 sine theta. Then here we have negative 2, negative 1, negative. So we add, that is minus 2 sine cubic theta minus sine cubic theta minus sine cubic theta. That will be 4 sine cubic theta. Now, if you look, our right hand side is the same as that in the given question. That is 3 sine theta minus 4 sine cubic theta, which is the same as what you have been given. Therefore, we say, therefore, that is hence proved. That is hence proved. So that is how to prove the given trigonometric equation. Okay, my dear student, let us see another example. This time, that is called example 2. That is example 2.
You are watching Darasa Online.
Find the values of theta such that, so we have a question which says find the values of theta such that sine 2 theta minus cos theta is equal to 0. And you have been given the interval that is from 0 degrees, that is less than or equal to angle theta, less than or equal to 360. Now solution, we have sine 2 theta minus cos theta is equal to 0. But remember, we know exactly the value of sine 2 theta because sine 2 theta, that is a double angle formula. So double angle formula for sine 2 theta is 2 sine theta cos theta. So this one is for sine 2 theta. Now minus, then again we have cos theta. So here this is cos theta, which is equal to 0. Therefore we have 2, that is 2 sine theta cos theta minus cos theta is equal to 0. Now cos theta is common. Cos theta is common. So we put out of the bracket, that is cos theta, bracket of, now we take 2 sine theta cos theta divided by cos theta. So we are going to have 2 sine theta minus, then cos theta divided by cos theta, that is 1, which is equal to 0. Now either, our solution will be either cos theta is equal to 0 or 2 sine theta minus 1 is equal to 0. Cos theta is equal to 0. It means we can shift cos theta by saying theta is equal to cos inverse of 0. Theta is equal to cos inverse of 0. Then just use your calculator to find the angle theta. So by using your scientific calculator, that is cos inverse, we have cos inverse, that is cos inverse of 0. That is cos inverse of 0. So theta will be equals to 90 degrees, or the next angle will be 270. That is 270. That is for cos theta is equal to 0. Now what about 2 sine theta minus 1 is equal to 0? Now for the case of 2 sine theta minus 1 is equal to 0. So we need to make sine theta the subject. So we are going to have 2 sine theta is equal to 1. So here you can divide by 2, divide by 2. So we have sine theta is equal to a half. But our intention is to find theta. So we can say theta is equal to sine inverse of a half. That is sine inverse of a half. So again, my dear student, you just use your scientific calculator to find the angle theta. So sine inverse, that is sine inverse of a half, that is 0.5. So that is equal to 30. That is theta is equal to 30. But there is another angle. There is another angle for sine, which gives the same answer, that is a half. So again, we have another angle here, that is 150. So we have another angle here, that is 150. That is sine of 30 is equal to a half, but again, sine of 150 is equal to a half. The same applies for cosine. Cosine of 90 is 0, and the cosine of 270 is equal to 0. Now, these angles are in this range. So therefore, we say, therefore, the solution will be, now we are starting with the smallest angle. Our smallest angle is 30. So we have angle 30 followed by, because we have 90, so followed by 90. Another one, we have 150. And the last one, we have 270. We have 270. So these angles are the solution, for the given trigonometric equation. Okay, that is our second subtopic called sine and the cosine rules. Since we are going to revise the questions concerning to sine and cosine rules, now let me recall. I will recall the formula for sine and the cosine rule. Recall the formula for sine and the cosine rules. Now, starting with the sine rule, that is A, call sine, that is sine rule. Okay? That is for three angles of a triangle, labeled A, B, and C, with respect with their respective sides. Labeled, we have A, C, that is A, B, and C. Sine rule states that A, that is side A over sine of angle A, this one will be equals to side B over sine of angle B. And again, this will be the same as side C over sine of angle C. This is what we call the sine rule. So this is a sine rule. Now, my dear student, let us see where we can apply this general formula for sine rule. Let's have an example here. That is example. And our example says in the triangle, A, B, C, side, we have side B, C, is equal to 8 centimeters, and angle BAC, this is equal to 51 degrees, and the angle ABC is equal to 68 degrees. That is 68 degrees. Now find the length of AC, correct to 1 decimal place. That is correct to 1 decimal place. So my dear student, we have a question which says in the triangle ABC, side BC is equal to 8 centimeters, and the angle BAC is equal to 51 degrees, and the angle ABC is equal to 68 degrees. Now we are supposed to find the length AC. Now let us make a sketching. That is a sketch for the triangle. So suppose this is the triangle. Suppose that is a triangle labeled A, B, and C. That is our triangle labeled A, B, C. Now the opposite of angle A, we are going to have the length A. That is, you can call that is A. And again, the opposite of angle B, we are going to have the length B. And the opposite of angle C, we are going to have the length C. That is C. Now, in the information, BC is equal to 80 centimeters. That is BC, which is the same as A, is equal to 80 centimeters. And the angle BAC, that is BAC. So we are talking about this angle, that is BAC, is equal to 51 degrees. And the angle ABC, we have ABC, this one is equal to 68 degrees. Find the length AC. So we need to find the length AC, that is B. Now, for such kind of a question, we can apply the sine rule. So here we have angle A given. We have angle A is equal to 51. But again we have angle B. Angle B is equal to 68 degrees. And of course we have A, can call A is equal to 80 centimeters. Now what is missing is B. B is missing. You don't have B. Now let us call sine rule. Let us recall sine rule as follows. You can say using sine rule. So starting with the sine A, we have length A over sine of angle A. This is equal to angle B is there. So we have B over sine of angle B. Now let us substitute the values we have. So A is equal to 8. That is 80 over sine of angle A. That is sine of angle A. Angle A, we have 51 degrees. So divided by 51 degrees, which is equal to B. B is missing. So here is B over sine B. What is sine B? So B is 60/80. That is sine 60/80. So here we cross multiplication this way and that way. So we are going to have B sine 51 is equal to 80 times sine 68. So B will be equals to 8 times sine 68 over sine 51. So B is equal to, then my dear student, use your scientific calculator to get the answer. So here we have 8 times, we have sine of 68 divided by sine 51. So we are going to have the length, that is B is equal to 9.5445 centimeter. But they said correct to 1 decimal place. That is correct to 1 decimal place. Therefore, to correct 1 decimal place, it will be 9.5. That is 9.5 centimeters. That is correct to 1 decimal place. That is correct to 1 decimal place. Now again, my dear student, let us see another rule, that is cosine rule.
You are watching Darasa Online.
Okay, for the case of cosine rule, there are 3 important formula. Formula number 1, A squared is equal to B squared plus C squared minus 2BC cos of angle A. That is one. And the second one, that is B squared is equal to A squared plus C squared minus 2AC cos of angle B. That is 2. And the last one, we have for C squared, this is equal to A squared plus B squared minus twice AB cos of angle C. Now, my dear student, let us see the question that is going to apply one of the formula. So here we have an example, and the example says find the size of angle C in the triangle ABC below. That in the triangle ABC below. So the given triangle, that is, we have A, B, and the C with 23.57 centimeters. Again with 16.4 centimeters, and we have 11.2 centimeters. That is the question we have. We are supposed to find the angle C. Now, let us see how we can apply one of the cosine rule to find angle C. So since angle C is missing, so we are going to use formula number 3. Therefore, solution from C squared is equal to A squared plus B squared minus 2AB cos C. Since C angle C is needed. So C squared, it will be 23.57 squared, which is equal to then A squared. So A squared will be 16.4 squared. That is 16.4 squared plus, then the next is B squared. What is the value of B squared? Of course, we have 11. That is 11.2 squared minus, then we have 2. That is 2 times, then A times B. So A is 16.4 times B. Our B is 11. That is 11.2 followed by cos C of angle C. Now we are supposed to make cosine of angle C the subject. So we are going to have, that is 23.57 squared minus, so we minus that is 16.4 squared, again minus 11.2 squared, which is equal to 2 times 16.4 times 11.2 cos of angle C. Maybe let us use scientific calculator to find this number which are squared. So we have 23.57 squared. That is squared. Of course, we have 555.54 minus, then we have 16. That is 16.4 squared, 394.4, which is equal to then 2 times 16.4 times 11.2. So that is 2 times 16.4 times 11.2, which is equal to 367.36 cos C. Now subtracting, which is equal to 367.36 cos C. Therefore, cos of angle C will be equals to 161.14 over 367.36. Now we just divide. That is 161.14 divided by 367.36. So cos of angle C is equal to 0.4386. That means C will be equals to cos inverse of 0.4386, 63.98. Continue to send SMS your questions and comment. Till next time, join with me so that you can proceed with the next topic. Thank you for watching.